Guidance for on-stream and off-stream inspection of filters based on API 570, API 572, and ASME, standards-based procedures for effective filter inspections. Purpose and scope of filter inspection, applicable codes, standards, and roles. The purpose of this presentation is to provide inspectors with structured and practical guidance for performing on-stream and off-stream inspections of filters used in process industries. Filters are critical pressure-containing components that protect downstream equipment, ensure product quality, and maintain safe operation. This guidance aligns with the intent and requirements of API 570 for in-service inspection of piping and pressure components, API 572 for inspection practices, and applicable ASME construction and design principles. The scope covers common industrial filters such as basket strainers, cartridge filters, duplex filters, and temporary or permanent filtration devices installed within piping systems. Inspectors must understand not only the mechanical condition of these filters, but also their operating context, service fluid characteristics, pressure and temperature limits, and historical degradation mechanisms. This section establishes the boundaries of inspection responsibility, clarifies what is included and excluded, and emphasizes that inspection activities must be risk-based, documented, and performed by qualified personnel. It also highlights the importance of integrating inspection findings into asset integrity management systems to support safe, reliable, and compliant operation over the equipment lifecycle. Effective filter inspection relies on understanding how API 570, API 572, and ASME standards interact and complement each other. API 570 defines inspection requirements, inspector qualifications, inspection intervals, and documentation for in-service piping systems, including inline filters. API 572 provides detailed guidance on inspection techniques, damage mechanisms, and practical field considerations that support API 570 implementation. ASME standards, such as ASME Section 8 and ASME B31 piping codes, establish original design, fabrication, testing, and allowable stress limits that inspectors must reference when evaluating fitness for service. This subtopic also clarifies the roles and responsibilities of inspectors. Engineers, operators, and corrosion specialists. Inspectors are responsible for performing examinations, identifying deterioration, and reporting findings, while engineers assess acceptability and determine repair or replacement requirements. Clear understanding of these roles ensures inspections are technically sound, compliant with standards, and effectively translated into integrity decisions. Common filter types and construction features, service conditions, and damage mechanisms. Filters used in piping systems vary widely in design and construction, and inspectors must be familiar with these variations to conduct effective inspections. Common types include basket strainers, Y strainers, cartridge filters, bag filters, and duplex or automatic self-cleaning filters. Key construction features include pressure-retaining housings, covers or closures, internal baskets or cartridges, gaskets, bolting, and drain or vent connections. Materials of construction may range from carbon steel and low-alloy steel to stainless steel and non-metallic linings, depending on service requirements. Inspectors should understand how these components are assembled, where stress concentrations exist, and which parts are most susceptible to corrosion, erosion, or mechanical damage. Knowledge of original design pressure, temperature, corrosion allowance, and ASME code of construction is essential for evaluating current condition against allowable limits. Service conditions play a major role in determining inspection focus and frequency for filters. Inspectors must consider operating pressure, temperature, flow rate, fluid composition, solids loading, and process upsets. Common damage mechanisms include general and localized corrosion, erosion from high-velocity or abrasive particles, fouling and plugging, fatigue due to pressure cycling, and gasket degradation. In certain services, filters may also be susceptible to corrosion under deposits, microbiologically influenced corrosion, or stress corrosion cracking. Understanding the relationship between service conditions and damage mechanisms allows inspectors to anticipate likely problem areas and select appropriate inspection techniques. This risk-informed approach is consistent with API 570 principles and helps prioritize resources toward the most critical integrity threats. On-stream visual and external inspection practices, on-stream monitoring and indirect techniques. On-stream inspection refers to examination of filters while they remain in operation. The primary objective is to identify visible or detectable signs of deterioration without interrupting service. Inspectors should conduct external visual inspections to check for leaks, corrosion, coating breakdown, insulation damage, abnormal vibration, and signs of overheating or process excursions. Particular attention should be given to flanges, covers, bolting, drain connections, and welded joints. API 572 emphasizes the importance of using all senses, including sight and hearing, to detect abnormal conditions such as hissing, dripping, or unusual noise. On-stream inspections should also verify that pressure and temperature indicators are functioning and within design limits. Findings must be documented, trended over time, and communicated promptly if they indicate an immediate safety or reliability concern. In addition to visual checks, on-stream inspection may involve indirect monitoring techniques that provide insight into internal condition. Differential pressure across the filter is a key indicator of fouling or blockage and should be reviewed regularly. Unexpected increases may signal internal damage, collapsed elements, or excessive debris accumulation. Temperature anomalies can indicate flow restriction or internal bypassing. Where applicable, non-intrusive techniques such as acoustic monitoring or external ultrasonic thickness measurements may be used to assess wall loss trends. Inspectors must ensure that measurement locations are consistent and that data is interpreted in the context of operating conditions. These practices support API 570 requirements for condition monitoring and help determine when off-stream inspection or maintenance is necessary. Preparation and safety for off-stream inspection, internal examination, and acceptance criteria. Off-stream inspection is performed when the filter is isolated, depressurized, and opened for internal examination. Proper preparation is essential to ensure safety and inspection effectiveness. Inspectors must verify that isolation, draining, venting, and purging procedures have been completed in accordance with plant safety requirements. Confined space, residual pressure, hazardous fluids, and sharp internal components must be considered. Before opening the filter, inspectors should review design drawings, previous inspection reports, and known damage mechanisms. This preparation aligns with API 572 guidance and ensures that inspection activities are systematic, safe, and focused on the most likely areas of concern. Internal inspection allows direct assessment of the filter housing, internal elements, gaskets, and bolting. Inspectors should look for corrosion, erosion, pitting, cracks, deformation, and evidence of bypassing or element failure. Thickness measurements should be taken at representative locations and compared against minimum allowable thickness calculated per API 570 and original ASME design data. Internal components such as baskets or cartridges should be checked for damage, plugging, or collapse. Acceptance criteria must consider corrosion allowances, remaining life, and fitness for service principles. Any findings outside acceptable limits should be clearly documented, with recommendations for repair, replacement, or re-rating as appropriate. Inspection intervals and risk-based approach, documentation, reporting, and continuous improvement. Inspection intervals for filters should be established based on API 570 requirements, adjusted using risk-based considerations. Factors influencing interval selection include service severity, historical corrosion rates, inspection findings, and consequences of failure. Filters in severe or critical service may require more frequent on-stream checks and periodic off-stream inspections, while low-risk applications may justify longer intervals. Inspectors play a key role in providing accurate condition data that supports interval determination. A risk-based approach ensures that inspection resources are focused where they provide the greatest safety and reliability benefit, while maintaining compliance with applicable standards. Thorough documentation is a fundamental requirement of API 570 and a critical element of effective inspection programs. Inspection reports should clearly describe the scope, methods, findings, measurements, and conclusions of both on-stream and off-stream inspections. Photographs, sketches, and thickness data should be included where applicable. Reports must identify any deficiencies, assess their significance, and provide clear recommendations. Consistent documentation enables trend analysis, supports remaining life calculations, and facilitates continuous improvement of inspection practices. Inspectors should also participate in feedback loops with engineering and operations to ensure that lessons learned from inspections are incorporated into design, operation, and maintenance strategies.